In this video, we'll see the design of differential amplifier. So go to File, New, Cell View. In the library, Demo, give cell name as Diff Amplifier 123. You can give any cell name and press OK. So differential amplifier has top current mirror, and bottom you have, in middle you have two transistors to implement differential amplifier. At bottom you have again current mirror. Okay, we'll implement the circuit. So to implement the circuit, go to create, instance, browse, GPDK 180. So type here PMOS, press close. Length is 1 micro, width is 15 micro, and press hide. After that, rotate and press one transistor here like this. Place one transistor here. So another transistor you have to place like this, but source should come at the top. But here you are not getting source at the top. To get source at the top, create instance. You need not to go to browse again, GPDK 180 cell PMOS. You need not to select it because already you have library GPDK 180. Already you have cell as PMOS. Already we have view as symbol. So in this, change length to 1 micrometer, width to 15 micrometer, and press sideways so that you will get source at the top. You rotate, you will get source at the top. So for that, press sideways. You press this, and after that, press hide, and you rotate now. So you didn't get, then again. So I think I have pressed sideways twice. How to create instance? Change length to 1U, width to 15U, and press sideways once. So I think now I'm getting. So in previous time, I think I have pressed twice. So after this, current mirror. For current mirror, short source and source. Make a extend connection to connect VDD pin. Short gate and gate. So substrate of PMOS is connected to VDD, and again this substrate is connected to VDD. So extend this connection for connection of remaining circuit. So in current mirror, gate is connected to drain of 1 PMOS. So this completes the connection of current mirror. So press P, give name as VDD, press hide, and connect this pin here. So this is current mirror circuit. After that, implement differential amplifier circuit by using NMOS. So for that, go to create instance. So here you have library GPDK 180, but cell is PMOS. So you have to change cell to NMOS. For that, go to browse. In library, you select GPDK 180. In cell, you type NMOS. Okay. Select NMOS. Select NMOS, and view should be symbol. So here, length you change to 1U, and width you change to 3U, 3 micrometer. And after that, place like this, so that source should be downwards. So here, place like this, one transistor. So if you place another transistor like this, source at the top side. So if you want source at the bottom side, you have to click side view. So for that, again go to create instance. Already you have library GPDK180 cell NMOS view symbol, and change length to 1U and width to 3 micrometer. Press hide. Before that, press sideways. Then source will come at the bottom. Press sideways and press hide. Then if you place like this, the source will come at the bottom. Now make these connections. Current mirror connect to drain of the NMOS. This current mirror connect to drain of the NMOS. Short substrate and substrate connection. And this has to connect to VSS. We'll connect that later. Short this source and source. Extend this gate connection for V2 pin. Extend this gate connection for V in pin. Extend this connection for V out pin. So now take P, take V1 pin, and direction is input, connect here. And again press P, take V2 pin, direction is input, rotate. For rotate press R and press here, place here. Okay, and press P, name, type it as V out, direction should be output, and place here. Now this should be connected to VSS. So instead of connecting to VSS, just I will name this wire as VSS. So to name this wire as VSS, go to ABC. In name you type VSS and place this on this wire. So this wire is now named as VSS wire, or connect this wire to VSS pin later. For placing VSS pin, connect this wire to VSS pin. Both you can do, because substrate of NMOS is always connected to most negative voltage. Okay. So now we have to implement bottom current mirror. How to implement bottom current mirror? Bottom current mirror, it is pull down current mirror. It is always implemented by using NMOS. Again, go to create instance. Here only you have library GPDK180 cell NMOS view symbol. Length you take it as 1U, and width you take it as 4.5U, and place one NMOS like this. So that source should be at the bottom. If you're trying to face one NMOS here, but source is at the top side. So when you want source at the bottom side, then you have to click sideways. So for that, go to create instance. Library is GPDK180, cell is NMOS, view is symbol. Length you change to 1U. Width you change to 4.5U. So I forgot to click the sideways. Okay, click sideways. So you got, click sideways and place like this. Gate should be inwards and source should come at the bottom. So now for current mirror, short gate and gate, short source and source. Connect the source to most negative voltage. So this I will connect to the differential amplifier. Here I will connect a current source. So here first I will connect a pin here. In test circuit here I will connect a current source. So substrate of NMOS is connected to most negative voltage. Substrate of this NMOS is connected to most negative voltage. I will connect VSS pin here. Take pin P, give name as VSS and place here. Press pin P, but give name as VSS, and direction should be input. Only V out is output, remaining everything is input. And press hide and press place pin here. For rotating, press R and place pin here. I placed here. So some NMOS has created here. I will delete this. Okay. Again, next press pin P. Give name as IDC, DC, current source, and place this pin here. place this pin here. This is a current mirror, short gate and drain of this transistor. For that, take a wire, short this gate and drain like this. So now differential amplifier schematic has been completed. So after this, do check and save. So you will not get any error if your design is correct. Then you can also verify that schematic check completed with no errors in Virtuoso window. So you can see here the length and width of this transistor have not changed. So this is 1U, 4U. This is 180 nano and 2 micrometer. This should be also equal to 1U and 4U. This have not changed. So you can change here only. You can select the transistor, right click, go to properties, change length to 1U and width to 4.5U. Okay, now it has changed. So before it was 180 nano and 2U, now it has changed to 1U and 4.5U. So if you already placed and you have not changed the length and width, then you can change it by doing right click and going to properties. You can change it. Again, do check and save and take the symbol of this. To take the symbol of this, go to create cell view, from cell view and press OK. So it is asking where the pins should be. So we'll place IDC V1 and V2 as a left pin. Let the VDD be the top pin and VSS be the bottom pin. Okay, this is the connection. This is how you are going to get the symbol. After that, press OK. So you got the symbol. This is IDC, V1, V2. Top pin is VDD. Bottom pin is VSS. Right pin is Vout. After that, do check and save. It will be saved in your library. So next you have to do test circuit. To do test circuit, again go to File, New, Cell View. So you can give any name. I will give differential amplifier 123 underscore test and press OK. Now to do test circuit, get the symbol which you have already stored. For that, go to create instance, browse in demo folder. In demo folder, so you have created a symbol in name of differential amplifier 123. Select that and in view you select symbol. Okay, you already created a symbol for differential amplifier 123. Right, in view you can select symbol and press close and press hide. You will get a symbol placed here. Okay, so after getting this, so you can connect VDD to 2.5 volts, right? VDD connect to 2.5 DC volt. For that, go to create instance, browse. You are going to select all the current source and voltage source from analog library. Select analog library, press VDC, close, give DC voltage as 2.5 volts, press hide and place here. So that positive terminal should be towards pin VDD. So for VSS also, you can connect a DC voltage of minus 2.5 volts. Create instance. So library is analog library, cell is VDC, view is symbol, it's already there. give DC voltage as minus 2.5 volts. Press hide and place here. Okay. So next is IDC. For IDC, we are going to connect a current source, DC current source. For that, go to create instance, browse in analog library. In this, you select IDC symbol, press close. DC current it is asking, give 30 micro. DC current it is asking, give 30 micro. Press hide and place this here, so that arrow mark should point towards IDC. Another end you have to connect to VDD. Another end you have to connect to VDD. Okay. So now for you have V1 and V2, right? So we'll make any one terminal ground, other terminal we will give the input. So for V1, now we'll make it as ground. So I will connect ground pin later. V2, I will apply a sinusoidal voltage. For that, go to create instance, browse, analog library, select VSine, view is symbol, AC magnitude, give it as 5 milli, amplitude, give it as 5 milli, 5 millivolts, frequency, give it as 1 kilohertz, 1K, and press hide and place here. So make all the connections now by taking a wire. This I will extend it out for ground connection. This I will extend it out for ground connection. This I will connect to VDD. I have already told you. This should be connected to VDD, another terminal. I connected this to VDD. This I will connect to IDC. This you connect to V2. This you ground. So I'm giving connection to only one terminal, one of the input now. I have both the inputs, right? I'm giving only input to V2. V1 I'm grounding it. So connect this, extend this for ground connection. So now take ground and connect to the negative terminals of all the voltage sources. Create instance. Go to browse, analog library. In here you select ground, view as symbol, press close here, and connect ground to negative terminals. This also connect here. Now for here you connect a pin with Vout pin with direction as output. Select pin P, Vout, give name as Vout, direction as output, and press hide and place this pin here. So after this, after doing this, press check and save. So after this, go to launch, ADEL window, generate ADEL window. So we are going to do 3 type of analysis. Go to analysis, choose transient analysis. Stop time it is asking, give 5 milli. So your frequency is 1 kilohertz, time period is 5 milli. So give stop time as anything. In 5 milli, you will get your frequency is 1 kilohertz. Can give any value, 5 milli you give. In 1 milli, you will get 1 cycle. In 5 milli, I think you will get 5 cycles. Accuracy, give moderate and press apply. And next, select DC voltage, save DC operating point, select component parameter, select component, select the sinusoidal voltage source, change that to DC. Again go back to the ADL window, start as minus 2.5 and stop is plus 2.5. So sweep from most negative voltage to positive voltage. Next, press apply. Next is AC analysis. Sweep variable is frequency. You will sweep from 100 Hz to 1 gigahertz. 100 to 1 giga. Sweep time is lifetime. Sweep type is logarithmic. Points per decade is 20. Press apply and OK. So go back to ADL window. Outputs to be plotted. Select on design. Select output wire and input wire. That is the wire which is connected to sinusoidal voltage. And press run button. So split this. So I'll make it a little bit thick. Okay, this is the simulation for your differential amplifier with V2 input and V1 as 0. So when you give V2 as input, and V1 as 0, your differential amplifier will work as inverting amplifier. So you can see here from the simulation waveform, you can see it's acting as inverting amplifier. If you get positive cycle, if you apply positive cycle, you're getting negative cycle. If you give negative cycle as input, you're getting positive cycle as output. And DC response also shows the same thing. If your input is low, that is most negative, your output is most positive. If your input is most positive, your output is most negative. So this DC characteristics also shows the same thing. It is acting as a inverting amplifier. So AC response shows that. So it is, the signal is amplified, right? So the signal is amplified and you're getting totally output as 510 millivolts. For the input of 5 millivolts, you're getting output of 510 millivolts. This output is constant till certain frequency. After that, the frequency is going to fall down because of internal capacitance becomes active at high frequency. MOSFET's internal capacitance becomes active at high frequency. So that at high frequency, gain starts falling down or V out starts falling down. Okay. So this is about your simulation. When you give V in and so now we have seen the simulation. When I give input to V2 and V1 is grounded. Next what we'll do, we'll give the input, this input to V1. So I will give the same input to V1 and I will copy and paste it. Okay. This I will delete. This I will connect to V2. I will connect to ground. So V1, for V1 I am now going to give input now. So I will give input to V1. Create instance ground and I will place here. So what I have done now, I have given input to V1 and I have made V2 as ground. So I will check and save it. So here there is no connection. It is showing error because the connection has not made properly. So I will place like this. The connection has made properly now. So now check and save it. Again go back to the ADL window which you have already done. Transient analysis, DC analysis, AC analysis, everything you have done. No need to do again. Which was minimized. Open that again and press run button. Now you will get the waveform for I think okay. So only you have to make this output to be plotted. Select on design. Only you have to make this. Select output wire and input wire. Because previously the input was connected to V2, right? Now the input is connected to V1. Only you have to make only you have to do this step again. Let's go to output to be plotted. Select on output wire and input wire. So after that, press on run button. So after this, when you press on run button, so if you make this extra thick, so you can see that the amplifier is working as non-inverting amplifier. Yes, it is working as non-inverting amplifier. When you apply input to V1 and you're making V2 as ground, the amplifier working as non-inverting amplifier, right? So for positive peak, output is also positive peak. For input negative peak, output is also negative peak. And you can also see that the gain is same almost. And in DC analysis, you can see that when your input is most negative, output is also most negative. And input is most positive, output is also most positive. This is the output curve. Okay. This is about simulation of your differential amplifier.